Okay, so vehicle network. So I chose vehicle networks for the update this time because CAN is 13 model years old now, and we're starting to see these systems not communicate for reasons other than the fuse blowing for pin 16. And I'm also finding, and I found this in the shop, that a lot of the cars that I get in that have network issues that are referred to me by another shop are things that really the shop should have fixed. I mean, they just weren't that hard, but the shop was uncomfortable or intimidated. So really the goal of this class is to give us some comfort, give us some confidence, so that when we have these cars that don't communicate with our scan tool, we have a systematic approach where we're going to go in and figure it out. Or if I have a car with a network code, I understand what it means and I've got some creative ways to fix it. Also at the after lunch, I've got some nice scope patterns here that show you what a CAN circuit looks like if it's shorted to power, shorted to ground, whether it's on CAN high or CAN low. And so that way you've got the book as a reference. So if you hook a lap scope up and it looks completely messed up, you can go to the book and go, oh, here's what's wrong. At least now I know what I'm looking for. And so that's it. So hopefully by the end of this, you guys will feel a lot more comfortable with it. So this was a fun class. I took this from an ATG class that we did, and it was really responded. So I took part of it and expanded it some to really make it fit our program. So we're section 1's the introduction. Section 2 is the diagnostic process. And section 3 is our control area network, or CAN. So we're not going to get to CAN until this afternoon. I normally break somewhere between 11:30 and noon. And normally we take a half hour for lunch, since there's usually not a long line at the restaurant you're eating lunch at. So it seems to work okay. So in the introduction, we have our diagnostic link connectors, network gateways, determining network topography, and induced faults. So it covers these different things. So when we talk about network and layering things through, we have two different things that we use. One is we think of a network as a physical structure. The other is a network of a language. And we tend to interchange those. So we are going to get into protocols as well as the physical layer. We're going to talk about topography. Do I need to make my own topography from a wiring schematic and try to make my best guess? Do I have a scan tool that supports topography? What does topography actually do for me? How is it going to help me diagnose the vehicle? And why is it important? And then what kind of faults can be induced into the system? So are these scan tool based faults? Is the scan tool actually creating the fault? Do I have communication faults? What are some things I might want to do if I have faults or things don't make sense before I jump down the rabbit hole and grab all the expensive tools in the shop and start trying to fix this thing? So under fault categories, communication faults. So the network issue most often comes up as the scan tool won't communicate. Is it the scan tool? Is it the DLC? Is it a module? Well, a couple things come into play. First of all, it depends on the network configuration. Am I talking to one module and it talks to everybody else, or do I talk to a network that's attached to all the modules simultaneously? What I can tell you is that probably 80%, if not 90% of network communication issues, after you eliminate power at pin 16, are a bad DLC. The pins get spread, the wires on the back of them get broken, things like that. So probably 80% plus of the time, you can't talk to a car. Once you make sure you have power at 16 and ground at pin 4 and 5, it's a bad DLC. And I used to keep a replacement DLC in my toolbox, actually a couple of them. And I've gotten cars sent to me from other shops because they wouldn't talk, and all it is a bad DLC. Because someone uses what, a probe or a round probe, and now opens the thing up, and now you put the scan tool in and doesn't make a good connection. Or the wires going in the back, someone's had the dashboard, someone's dropped it, and they hung the lower valance with the DLC and the wiring, and they pulled the wires off the back of it, or broke the wires going in the back of it. So that's probably the most common thing that I see. That's like my first thing I check after I get through the pins 4, 5, and 16. is the DLC. And like I said, most of the time, that's my communication problem. If I can't communicate after that, now we know we have a real problem, and we got a couple ways we can address that.
Do you solder those wires in when you make that connection, or you just?
I crimp and heat shrink.
Yeah. Okay. All right.
You know, a lot of manufacturers have gone to not soldering. You know, and part of the reason is people don't necessarily solder well. Sometimes accessibility, trying to solder upside down underneath the dash isn't fun. But the big thing is what they were finding is because people weren't soldering correctly, they were putting excessive resistance in the circuit with the solder joint and
cold joint
problems.
Cold joint, yeah.
Yeah. So it's not that soldering's bad, it's that people don't do it where the darn and it's hard to do. So I've always used, from accessibility, it's easy. I use the non-insulated solderless connectors, crimp them on, make sure I got a really good connection, then slide heat shrink over it with the good stuff with the glue inside, and that thing's going to reinforce that connection. That thing's never getting water in it, and it's never going anywhere, and I don't have really any resistance in the connection. So that's how I prefer to do it. But I know people that still prefer to solder.
Yeah.
I mean, if you're good at it and you like it.
So you just slide a heat shrink on it and then just melt it, huh?
What's that?
So you just slide a heat shrink on it and just burn it up. And
Yep. Yeah. And the good heat shrink has like a glue on the inside that you'll see it ooze out each end. That thing is glued solid in there. I mean, that's
they got the solder heat shrink. Have you seen those?
Yes.
It's a heat shrink with solder inside, and as you're heating it up, it actually solidifies and
that's nice.
Solders your connection.
Nice
yeah, I've seen that too. Kind of like the pellets they use in some of the battery cables.
Yeah, same
the
thing.
battery
Same
cable end and,
yeah.
And it wicks out. Are you able to use flux with those?
I don't think so.
I don't think so. They just melt it. Yes.
Okay, so it must have flux already in the solder pellet.
Yeah, it's like rosin core or something.
Yeah. It just you just point heating up and it just melt it and just sticking on it.
Yeah. So basically now we're doing pipes where we fill it up and watch the solder wick out.
Yeah.
Right.
The interstate battery truck they sell that thing.
Yeah. And they also have the crimp connectors with the heat shrink built on, like you get from GM if you buy a pigtail. And it has the heat shrink built into the solderless connector, and then you heat it up. And if you buy a wiring pigtail from GM, they come that way. I don't like those because my eyes are so bad I can't hit the hole in the solderless connector with the wire. So that's the other reason why I use separate ones, is because I can actually see what I'm doing. So every communication problem, has to do with the scan tool. However, many diagnostic solutions involve the scan tool retrieving codes that report problems between modules. Is the code set because the scan tool connected? Some networks only work when you talk to a scan tool. Do I have codes and I clear the code and it's a hard code, but yet I can talk to everybody in the network? Why is that? A lot of times we ignore those codes because it's not turning the light on, and it has a network code, but the light's not on, it doesn't go away, and everything works. So have a nice day. And we're kind of left with, why are we getting a code? I'm trying to answer that. So some of it is a matter of looking to see what does or doesn't work. So if I have communication with all the modules and network codes, then a network issue is one of the options, a possible list. But they don't scream a network fault. So I can have issues. I got some case studies in here where I might have a malfunctioning vehicle that doesn't scream network. I don't have any network codes, but yet it's a network problem. And because of how we share information in vehicles today, right? If I get corrupted data, don't get data, whatever, it's kind of a network problem because we're using the network. So is the network bad, or is it just not conveying the information? Or is there a module that should be working that's not? So our network is a physical network, consists of a series of control modules that communicate information and requests with each other in a digital languages over one or more circuits. So that is our physical construction. That's our house. That's the framework. But then we have digital languages called protocols. And this is the electrical aspect of the network. So when we hear CAN, am I talking about the physical network or the protocol? It's a fair question, because they're really two different things, aren't they? Right? And depending on which speed of CAN I'm using, it's going to change both the language and the framework. So it's, it's important as we talk, and I don't care if it's class 2 or ISO 9141 or any of the other protocols we have the language, but then how's the network built? So the language is important because if I'm going to put a scope on it, I need to know what language is being spoken. I don't need to understand the language, but I need to be able to recognize it. And everyone in this room recognizes languages they don't speak, but yet they're able to recognize it as that language.
So what language they talking?
Right. So if someone's speaking French, I don't speak French. I know a couple words. I know enough to figure out they're speaking French. If someone's speaking German, I can listen a little bit and probably figure out they're speaking German or something very close to it because I'm familiar with those languages. So I have a point of reference, and then I can figure out, I don't know what's being said, but I know what they're speaking. And same thing is true with our digital languages. I don't need to know necessarily what's being sent, but I need to understand the rules. What voltages does it use? What does information kind of look like? What are some of the rules it has to follow? Does it use a bias voltage? Does it not use a bias voltage? Is it at 0 volts when it doesn't talk? Is it at 7 volts when it doesn't talk? Is it 11 volts when it doesn't talk? Is it 2.5 volts when it's not talking? What does the voltage look like when it does try to talk? So those are questions. And Eduardo, if you can get your camera back on, please. And so that is, what we're constantly dealing with. So as we go through here, we're going to work on trying to recognize some of these. I got some common ones in here. So why a network? Well, the primary advantage of networking is that complex information can be shared between modules without having to hardwire all of them. So, I can put stuff on the bus and I can share it with multiple modules. So instead of having information from the ABS go to the PCM, go to airbags, and go to instrument cluster all separate wires, we can just put on the bus and now everyone can see that information. It also saves miles of wiring, but also increases reliability of systems by reducing the number of connections and splices that can fail. So the fewer connections we have, the fewer things that can go wrong.
Do we have redundancy on this bus? Is it single bus or
Depends.
Bringing up?
Great question, and we'll see. It depends. Some buses have great redundancy, have a lot of fault tolerances. Other ones are kind of one and done. Yeah, and Eduardo, I need you to keep the camera on, please.
Yes, always there.
What's that? So that's where we get. So, we use the wheel speed example in the book, and modern vehicles don't use a vehicle speed sensor anymore. Why? Because I got 4 wheel speed sensors. So back to your question of redundancy, Daniel. So I have redundant wheel speed sensors now. I got 4 of them. I don't have a redundant ABS module.
Oh,
right?
Okay.
Yeah.
Okay.
So
Okay.
that's what I mean. Some areas, yeah, I have great redundancy. I got 4 wheel speed sensors. So my speedometer is not going to drop out because I have one sensor go bad, which is what used to happen. But by the same token, if my ABS module goes out, I no longer have wheel speed. And not only do I not have wheel speed, my transmission doesn't have it, my airbags don't have it. So a lot of decisions that are speed dependent, my suspension system doesn't have it. So all kinds of things that are speed dependent, now we're working with a backup strategy because they're not getting the information they want.
Well, I'd imagine ignition and fueling too.
Yeah.
Speed dependent.
Right.
Yeah.
We want to know what's going on. So like I said, some areas we have redundancy, some don't. And when we look at network structure, we'll see some networks have really good redundancy. Other networks are, you're done. But that's also why we have more than one network on the car. Because like a modern Porsche might have 168 modules. We don't put 168 modules on one network because if that network went down, if it was shorted, no one could talk, no one could do anything. So we break it down into
168
smaller
module
areas.
on modern Porsche. Wow.
Yeah. Yeah, 2018 Panamera up to 168 modules.
Wow. That's a
That's
lot of
if you
money.
get the fully loaded one.
Well, is that a hybrid or just a regular Porsche Panamera?
I am not sure.
Oh, okay.
I have a friend of mine who's a Porsche tech, and he was showing me the stuff. I don't remember if it was hybrid or regular,
Wow. Yeah.
but that is a lot of modules. So you can see why we have a lot of networks. So, and again, we talked about a couple of things, but what about speed sensitive wipers, speed sensitive radio volume, auto locking features, the rear wing going up to make you look cool going down the road, right? All those things rely on ABS. So, I mean, we're really taking this one piece of information and sharing it with a lot of systems for them to operate. And it's certainly conceivable that we might have a customer that only complains about one of these systems, right? They don't care that their wing doesn't look cool to going down the road. That's their biggest concern. Or their radio volume doesn't adjust anymore. So the complaint we get might be a result of a problem, not the main problem. So why so many networks? To reduce vulnerability, manufacturers have isolated networks into groups of modules that are most related. Sometimes I don't know where they think they're related, but to reduce cost and increase fault tolerance, manufacturers use slower speed networks where reduced speed does not compromise system functions. So ADAS has a pretty fast network. Your infotainment system has the fastest network because of large video files and things like that. Powertrain management's probably third in line. And then we get into slower systems, Windows, radio, climate control, right? So if I hit the button on the radio, does it really matter? It takes 300 milliseconds for the window to start moving. Is the customer going to complain about that? No, because to them, it still seems instantaneous. So why have a high speed network that can do it in 30 microseconds? It's not worth the money because the faster the network, the less fault tolerant it is as a rule, and the more expensive it is to build. So consequently, things that are slower functions, I want the sunroof to open, it's going to be on a slower speed network. I hit the button, we can wait 300 milliseconds before the sunroof opens. No one's going to complain about a third of a second delay. Most people, I don't think, would notice. It would still seem instantaneous.
What's the light switch? What's the light switch when you hit your light switch in the house? The switch goes on faster than the light turns on. How many milliseconds is that?
Boy, that's close to instantaneous.
Yeah, but you can still see that little.
You
right?
can't.
The switch is on, but the light hasn't, and then it hits. So
exactly, you can see that there is a delay. Certainly, if you toggle it back and forth. So yeah, you can see that. And is that a delay, or is that a delay in your eye's response and your brain?
I don't know. All right.
You know, that's what I mean by it. But see, that seems instantaneous to us. I turned the switch on, the light came on. Yes, I know there is a slight delay, just like turning the headlights on your car.
There's a delay.
That's like a slight delay, but at the same token, it seems instantaneous.
So that depends on what kind of light bulb you use too, you know?
Right.
You have
right. Because we got to heat the filament, or we got to, but to us, that doesn't set an alarm off that it's not working. And that's the point I'm making. So even though we hit the light switch and it takes whatever that fraction of time is for the light to illuminate, because we got to heat it up, or it's a fluorescent, so I have to light off the ballast and get the gas going, whatever, it appears to be instantaneous, or it appears to be quick enough of response that I don't think, oh, shoot, is the light working? Right? And we've all had that, like a fluorescent with a bad ballast where it takes longer to light off. You kick it on, it's like, why did the lights come on? Then it finally comes on. It's a noticeable delay. So, you know, what is fast electronically is not necessarily, we don't need that maximum speed every time for our perception that we have as human beings before it triggers that response of I hit my window switch and the window didn't move. Now I hit the window switch and it's moving in a third of a second, half a second. It still seems pretty instantaneous to me. Even though electronically we know from fast signals that that's a hell of a long time. So that's where I'm at. It's really about that perception that we get. So vehicle modules. So this is just an example of some of the different modules that we might see on a vehicle. And obviously some of these modules, if you have one, you don't have the other. Again, speed is more expensive and it's less fault tolerant. So the engineers are balancing that out. So networks versus protocol. For the purpose of this manual, a network is the physical wiring layout. The protocol is the language that's spoken on the layout. So we're going to talk about physical layouts and we're going to talk about protocols. So we're going to talk about them separately because I can have different protocols on the same physical layout. So we need to understand what might be a protocol problem versus what might be a hard or foundational problem. So for example, the cable to your house is the physical conduit for information transfer, but one cable can deliver data in different forms or different digital languages over a single coaxial cable. Get high-speed internet, a bazillion television channels, radio, and phone service all through the same cable, right? I mean, I'm here talking to you guys. My wife's in there probably streaming a movie. And she may even talk on the phone all through the same cable. So it really, so that's where the physical layout is the cables I put in the attic and the walls. The language is what's being used to convey the information. And that's why when I have a problem, my first question is anything working? Oh, we don't have cable, but the internet and phone work fine. Guess what? That's not a physical structure issue. That's a language issue. So the next question is a language issue here or is it a language issue there? On the other hand, if nothing's working, I've lost phone, internet, and cable. Guess what? That's a structural issue. Who hit a telephone pole? So protocols. Keep in mind the computer only has 2 letters in its alphabet.
1 and 0s.
1 and 0. So I have to convey the entire English language and every number in 1s and 0s. And we do that using groups of 8 bits called a byte. And since there's only 2 numbers in the computer alphabet, they toggle these bits 0 and 1 for a total of 255 or 256 combinations if you have everything off and you have a 0. But basically 255 is what we're used to seeing in automotive terms. So I've got, by toggling these 8 bits, I can get 256 different combinations. That's pretty amazing. Someone a lot smarter than me figured that out. And so that's how the computer is able to send so much information in that digital language.
What's 1 and 0, Brian?
What's that?
What is 1s and 0s?
Okay, so 1 and a 0 would be like an on or an off. So this is a 0, this is a 1. So if I have 8 bytes or 8 bits, excuse me, for 1 byte, my first one has a value of 1. My second one has a value of 2. Third one has a value of 4, 8, 16, 32, 64, 128. So what we do is we turn these on. So if I want 129, I would leave the last one on, if I can even do that. And I would leave the first one on. Now I have 129. I have a 128 and plus a 1, 129. So you're adding up. So I want to come up with 65. I turn on the 64 would have a 1 and the 1 would have a 1. Everything else would be 0. So it's able to maneuver those to get, and then the computer knows that, oh, 63 is F or 63 means this. So we're able to now have a much bigger language than just 2 digits by manipulating that.
Got it.
And if I have them all off, that would be 0. That's your 256th option. But on computers, like in mode 6 or any of that stuff, we see 0 to 255. We never see 256. So that's the scale we use in automotive, is that 0 to 255. And then what they did is they also converted that to hexadecimal, which gets us our 65535, which is the maximum amount of data in the hexadecimal language that we use in OBD2. So amazing. We've leveraged this 1 and the 0 to 65,565 combinations. I'm sorry, 65535, 35 combinations. Yeah, you can record the class if you have the capability of doing it. Also, I do record the class, so I do have a link, and I can always post that also if you want. So we talk about voltage range, and we talk about message structure. So in the message structure, we have headers, says who it's coming from, maybe who it's going to, priority, state of health, I'm alive, wake up commands, I want you to do something. And wake up commands can be different on different networks, both in construction and protocol. So we can use the same network protocol, but one may have an internal wake up circuit. Hey, we're sending a message through the network. Another one may have a hardwired network circuit where there's another wire. Hey, wake up, you got something coming in the mail. So same network protocol, but one uses an external wake up, the other one uses an internal wake up. So there's a lot of variations. You know, when we look at these structures, especially CAN is kind of an open source protocol. It's real loose. It has a few guidelines, and then it's kind of open to how the manufacturers use it. So I like to compare it to an Android phone. You know, if you have an Android phone, which is an open structure, it allows people to really do a lot of things with that same operating system. Not all Android phones look the same, work the same, do the same stuff. So there's some consistencies in them, but there's also a lot of differences because that's an open structure. Same thing is true with CAN. So generic OBD2 protocols. So we have our J1850 PWM, which is Ford, uses terminals 2 and 10, 0 to 5 volt range. Ford calls it their SCP system. Our J1850 VPW is the one we normally think of. That's GM class 2, 0 to 7 volt range on pin 2. So single wire network, J1850 PWM, 2-wire network. Same basic protocol language, different voltage ranges, different, one's a 1-wire network, one's a 2-wire network. So we see what I mean by some of this open structure. Our ISO 9141, that's our K-line, pin 7, excuse me. It could also use, and very few of them did, but they could also use terminal 15 as the L line. And again, this is a pre-CAN network, but ISO 9141 normally only used pin 7, but the 14230 now made it a 2-wire network. The interesting thing about ISO 9141 is it's only active when you hook up a scan tool. That's why, hey, I can't talk to this Volkswagen, but the car runs fine. Because that network's only used for communication. We also have the KWP 2000. Again, terminal 7 may use terminal 15, slightly different voltage ranges. And of course, our ISO 15765, AKA CAN. CAN's a little more standardized than the others. It's going to be only on pin 6 and 14. And it uses 2.5 volts at rest. And we have CAN high and CAN low. And CAN high goes from 2.5 to 3.5 when it talks. And CAN low goes from 2.5 to 1.5 when it talks. So this is the generic protocol. Now there can be other, and there will be other CAN systems on the vehicle that may be even connected to the DLC. There are several CAN systems that will not be connected to the DLC. they are not necessarily going to follow these protocol rules. They're not going to follow necessarily these bias voltage rules. They may not even be 2-wire, depending on the speed of the CAN system. But fortunately for us as diagnostic guys, as of 2008, with the exception of 2 models, the Chrysler Crossfire, and I can't remember the other one in 2008, everything 2008 and newer under 14,000 pound GVWR is CAN. And it has to follow the same rules. So now it doesn't matter what the emblem is on the car. I know what the language is that I should be talking on our OBD2 system. Now, keep in mind, some vehicles will have it has the ability to some systems will have multiple networks going to the DLC. So I may not get everything on one network. So that is something that is going to really vary by manufacturer. I may only have one network hooked up to the DLC and I talk to everything and all the networks on the car through this one network, or I may have multiple networks going to the DLC, and that can also affect what your scan tool can access. So, a lot of quote unquote code readers are actually now talking to ABS. They're talking to some of these other modules that are on that generic OBD2 network, but they can't talk to the sunroof. They can't talk to the front headlight module. They can't talk to those things because those aren't on that network. It's a different network. So that is, moving. Let's see. So network hubs, a hub, if a module has multiple legs on a single network connected to it, like a noded star network, then the module is central to the network, is acting like a hub. So hubs move information. They don't translate information. Much of the information modules receive from each other pass through the hub, which are passive devices. The information just passes through. So they're kind of like a connection, or just like a hub would be on your computer at the house. You're like a USB hub. We're just plugging more USB things in, and it's magically finding where it needs to go.
Name an example. Name an example of component or what? Dashboard cluster. What would
Not
be a hub?
necessarily. It's going to depend on network design. So I can't give a component example. I will give some examples of our hub where we're doing this, where we have a hubbed module.
Okay.
So I do have a picture coming up on that. But it's going to really vary by manufacturer, because what's important to one manufacturer is not important to another.
Do they piggyback them? It's a piggyback on a circuit board inside a module somewhere, or is it actually because a hub can be just an actual physical connection?
Right, and that's really that's what these are. These are a
physical layer one. It's layer one physical network, so it could just be an actual splice, really.
Exactly. Exactly, and it's probably and that's what I'm saying. It goes through without being changed. So normally it is basically a splice in a computer, and it's not changing. It's not. No. There's no traffic cop there.
Nope. No. Okay.
So we're on the same page now. So different manufacturers are going to make different modules a hub, but it's just a pass through, no traffic cop, no word police, whatever goes through goes through. So if a module is wired like a hub but connected to multiple networks, not just multiple legs of a single network, it's a gateway module. Whether it's labeled as a gateway module or not, that's the function it's providing. So a gateway module is a translator. A gateway module is connected to more than one network, means it speaks more than one language, and it can be attached to 3 networks. And we've seen that. So a gateway module translates. So if I am going through one network and and I'm talking to a module on another network that I'm not physically attached to, I'm basically talking to the gateway module, and the gateway module is interrogating the module I want to talk to, and then it's coming back with the translated information. So Vehicles can have more than one gateway module, although one gateway module will be the primary gateway. Older systems only had one gateway between networks. Hard to believe manufacturers figured out that maybe that's not the best idea for a couple of reasons. One is redundancy, obviously. The other is, why should I have an HVAC module, for example, that I want to have on a high-speed network and a medium-speed network? Well, if I put it on the medium-speed network, it needs to go through the gateway to talk to the high-speed network. And if I put it on the high-speed network, it's more expensive and needs to talk to the gateway on the low-speed network. So let it talk to both networks, because it has things it needs to do with people on both networks. Cuts down the traffic through the main gateway module, and it can act as a backup gateway module in case the main one goes down. So we see this with other modules. Human to vehicle interface module is another one that may do this. That, hey, there's things on both modules I want to use, and I want to use a lot. So instead of gluttoning up or building a bigger primary gateway module, we're going to leave that main gateway module, and we're just going to give gateway functions to another module. But if
So
it's
whether the gateway module go bad and the whole system shut down.
because now I can't talk to those modules on the other side of the network. And if the gateway module is the module I have to go through to talk to the car, I'm not talking to anybody. And so after our break, I've got some examples that we'll see where I got to go through a gateway module to talk to anybody. So, as a matter of fact, the only module I'm talking to on the car, even though my scan tool is 30 modules, I'm only talking to the gateway module. So if the gateway module goes bad, I'm talking to nobody. Even though the car may still start and run, I have a lot of lights on in the dash, but I can't talk to anybody. Gateways are not passive like hubs. They're used to translate. So really, a hub, single network, passive, it's not changing anything. Gateway, two networks, it's a translator. Many times a gateway is also a master module, although the master module and gateway module can be separate. But many times, and we'll see in some of these network configurations where the master module has to be the gateway module. So here's a Ford gateway example. In this case, this is from a 2016 Explorer. The DLC is actually a module. And we can see here that if we look in here at pin 6 and 14, which is our normal high-speed CAN, it looks like it's just passing through. But yet we know this is a gateway module. So the wiring schematic's not showing everything that's there because it has to talk to it, because you can see these other networks that come in here on the right terminate at the gateway module. So the gateway module has to be able to get that information and put it on the DLC for you. But yet, even though the schematic shows no connection to the DLC inside the computer. So this is a good example of where we have a gateway module, it's listed as a gateway module, but yet the wiring schematic doesn't show the information going in. It makes it look like it's a straight pass through to the DLC, when in reality it can't be.
Well, would it be because of the software is making up the link between 614 and right?
Yeah, exactly. So
the software is the language is what's picking it up.
Exactly. And there's language in the module that's connecting the two networks that are going to the DLC to the networks that are not going to the DLC. So obviously there has to be an electrical connection there, but yet through the schematic, it's a wire that just goes through it. It can't be right. So another example of a manufacturer not telling us everything. There's a surprise.
Is it because they're stupid, or they just want to withhold information so that you have to go to the dealer? Because I know,
I really think it's need to know. I think that this is done by engineers and figuring out, well, it's above our head, Daniel. Don't worry your little head. It's complicated. You're not an engineer. We're going to draw it simple for you.
Oh, yeah. Caterpillar does that a lot.
I think they all do. We're just dumb people that try to fix stuff, right? I mean, we don't need to know how it works. What are you, new?
I know, yeah.
So here is another example. This is Chrysler. And in this case, this is a topography screen from the Chrysler factory scan tool. So I also have a legend on the left. So what we can see is my DLC. I have a pink line that comes from the DLC to my gateway module. From my gateway module, I have a black network on the left, which is my high-speed CAN, and my network on the blue is my medium-speed CAN. So if I'm going to talk to any module on this car, I'm going to have to talk to the gateway module, which is the TIPM in this case. So if I can't talk to anybody and it's not a DLC problem, then guess what? My gateway module is my first suspect.
I've had them, the other modules short and somehow taken down the gateway.
Yeah. And that shouldn't happen. I mean, I can see it, you know, because the networks are isolated. You should still be able to talk to the gateway, but the gateway not be able to talk to the modules on the shorted network. But things don't always work as planned. Yeah, it shouldn't have done that, but I mean, weird things happen with networks, and some things aren't always how they should work.
I think it was just mostly voltage. It was a short putting voltage on one of the CAN lines or something.
Yeah, and we've done that. We put voltage on the CAN line, and it's definitely taken out the taken down the network, but we haven't seen it go through a gateway or cause a gateway that's talking on another network to stop talking. Now, if I'm using the shorted network to talk to a gateway, I can't talk to it. So I can't get to the modules pass. So, for example, if the CAN line in purple there was shorted, I wouldn't talk to anybody. But I have not had where either the high-speed CAN or the low-speed CAN on the Chrysler systems has caused the gateway to go down. On the other hand, I have had the gateways go down. They're a high failure item. I'm going to show you a neat trick in a little bit on how to get around it on some of these systems. Here is another system. This is a non-gateway system. So this is also Chrysler. This system has gateway modules in it. We can see that there's 3 of them, a primary and 2 secondaries, but the DLC talks directly to both networks. So here, I'm not going through a gateway to talk to a network. I'm talking to the network. I'm on the network with the scan tool.
Is it the same speed on all different the 2 networks?
What's that?
Is it the same speed?
No, different speed. So one is high speed, one's medium speed.
Okay.
Can we identify the high speed by CAN high and CAN low, right?
Yeah, exactly. And it has
All
a little
these are-
legend here that tells you what each of the networks are. That's hard to read on the PowerPoint, but they have a little legend they put there. But yeah, the different colors notate that it's a different network, different speed network.
Hey Brian, any way you can point the mouse to the picture while you're talking or no?
Yeah, I can. It's a little harder. I apologize. My
There you go.
is not in a good spot, but I might look a little funny on camera, but I can see my third screen now. So here in the black is one network. The blue is another network. The stuff that is in gray is optional modules. So those are modules that are not on this vehicle. So if we see it grayed out on the topography, that's all the optional stuff. Those are the bells and whistles this customer didn't buck up for.
That is a single wire.
No, these are 2-wire networks. So that's why this is a topography, not a wiring schematic.
So all the yellow, is it a gateway?
No, the yellow is just splices or combs, if I was to use GM terms. So
Okay.
these are splices. These are my 3 gateways, 1, 2, 3. So I'm gonna have a primary gateway and 2 secondaries. And then the modules in blue are all the modules that are present. Modules can be different colors. As we see, we have a gold here based on condition of the module, and all the grayed out modules are not there. So this is Chrysler's topography screen. So I'm going to show you a couple of different manufacturers that do this. The ones I'm aware of are Chrysler, BMW, and Nissan. One of the questions that's come up in previous classes is, are there any aftermarket scan tools that do this? Not that I've seen yet, but I got to believe it's just a matter of time. Because I think as more and more of these manufacturers do this, and the fact that our aftermarket scan tools are becoming PC supported now, they're Windows based, how hard is it for them to put this in there? You know, so it's definitely something I think we're in the next 5 years, I think we'll see it start hitting some aftermarket scan tools. But see here, my scan tool talks to the DLC. There's two different networks. These happen to both be 2-wire networks. So this is not a wiring schematic, it's a topography screen. It's just showing how things are touching each other, connected to each other. So single wire networks. So we had a lot of single wire networks prior to CAN, and we still have single wire networks. So GLAN, which is GM's low speed CAN network, goes to pin 1, is still a low speed CAN network. So we still use low speed CAN single wire networks. And we use other single wire networks also. So even some of our very fast networks can be single wire. So we look at some LIN protocols and some other stuff that are single wire networks.
And we, of course, everybody's shielded, right?
Well, no.
No.
How
can we get this high speed? What's the frequency? What's the bus rate?
It depends on the network. These are pretty low. These are, so CAN A is down, what, at 10 kilobits?
That's not even really that fast.
Right. But it's fast enough to convey the information, but it's slow enough that the EMF is not as much of an issue.
Okay.
Right. I get into something like copper most, where I'm in microseconds with a 50 millivolt switch that I'll show you at the end of the class. Noise is everything because a signal looks like noise, right? I mean, you're only switching 50 millivolts. Boy, shielding is everything. So that's why a lot of most is fiber. So it really depends. But they tend to shield them as necessary. And not all 2-wire networks are shielded like we would think they'd be. A lot of 2-wire networks, because of the inverse relationship of signals, provide some shielding. Twisted wires provide some shielding. And it's also where you're using the network. If I'm using the network in the trunk, I probably don't need as much shielding as if I'm running it in the engine compartment.
Now, say you get in there and you have, this happens I get cars from body shops, and whatever, that's CAN wire. I don't know what network wire it is. I see it. It's been butt connected, and that's the issue. What is a good way to get in there and do this repair?
I've
sell
used
a body harness.
Yeah, that's a good way. But I've gone in there and fixed networks with solderless connectors or solder. And usually what I do is it's all about twists per inch if it's a twisted pair. So I kind of count the twists per inch, and then I over twist to do the connection. So it kind of relaxes. And then you just got a small spot. If I can stagger the splice, I can. So instead of having... It's okay. It's okay. Hey. So, lady. Yeah, you guys are self-protective.
Dogs, those are barking.
Brian's dogs.
Yeah, they're my dogs.
Right, there's strangers in the house and they start barking.
Yeah, he's waiting for the.
I have the HVAC guy coming out of the attic. They just saw him walk by my French door behind me. So they're being good dogs. They think they're just timing's horrible.
So the single wire network is we only see the kind of not the modern coil. You mean the newer coil? Because they slow.
Oh, we still see single wire networks on newer cars.
Okay.
It's about cost and weight, right? If I got to double the wires, I've doubled the weight of the network physically, doubled the cost of the wire. And do I really need it? And I'll show you where a single wire network can be very reliable, depending on how it's made. So I don't necessarily lose reliability with a single wire network. A 2-wire network does not make it more reliable. Many times it's less reliable. So I'm saving money. I'm not losing reliability. Why wouldn't I still use a single wire network for a lot of these slower systems, or even some of these fast systems that I'm going to show you are single wire networks? Because they're very localized. So for example, between the instrument cluster and the steering wheel controls, that's a single wire network coming up the steering column. Well, it's only going this far, right? I mean, it's not going very far. Why do we need to run 2 wires up the steering column? Let's run a single wire. It's a very high speed network, but yet it's 1 wire. And it's a different protocol. It's a LIN network. So we do have a lot of single wire networks on modern cars that are still coming out today.
So what they use on the kind of like video camera on the
See, now you're getting
cell control
video camera
drive.
right? So videos. So if it's a backup camera, that's a pretty slow network. That's probably a medium speed CAN network. Or a lot of them, they use a direct feed where they're using coaxial cable from the camera all the way up to the module, the monitor. They're hardwiring the cable. Other manufacturers, they're putting it on a network, but a lot of the cameras are actually not modules. They're just a hardwired camera going straight to the module.
Yeah, RCA or RG56.
Yeah, I mean, when I was doing an ADOS training, I was back in Ohio for some ADOS training a year and a half ago, and one of the neat tricks they showed, we had a GM there. You want to diagnose the backup camera circuit. We unplugged the backup camera and we hooked up Pac-Man. And when Pac-Man showed up on the dash, guess what? That means that the radio assembly and the coaxial and everything's good. The camera's bad.
No, I mean on the core, like self-driving, they need it fast.
Same thing. Self-driving. Some of the cameras are modules. Some of them are just feeding a video input to a module. It depends on the manufacturer. Now, if I'm talking radar are modules. So the radar is going to be on the network. It's going to be on its own network. But the cameras are not all modules. A lot of them are just dumb cameras hooked up to the main module. So it depends on the manufacturer with the ADOS system. And that's why it's important to look and see what you're working on, how they build it.
Got it.
So, I mean, some stuff I could say, like in the case of a radar, I have not seen a radar on anybody's car that's not a module and not on a network, but I've seen a lot of cameras that aren't. So, so some stuff I can, make a better generality on. So it says not fast enough for modern powertrain control. That's true. Not even fast enough for many body and chassis systems. Not resistant to electromagnetic interference. Not redundant, but it can be. So we think of redundancy in a linear path, right? If I'm going down a line and the bridge is out, I can't get there. Well, what if I'm in a circle? Which means I just got to go around the long way through the other bridge. I can still get there. So we do build some redundancy into some single wire networks. It depends on how we built the network. Is it a series network, or is it a daisy chain that goes around in a circle? I mean, so there's different ways we can do it. And I'm going to show you some of those coming up here in a minute. So dual wire mirrored polarity is self-shielding because of the mirrored polarity. That's one of the things that makes CAN very effective on our high-speed CAN is we're going up. We're going high and low at the same time. So anytime we talk, we're canceling each other out. And so it becomes self-shielding, very stable. Redundancy is questionable. So most dual wire systems are not redundant. Some will run in what's called single wire mode. And I got a screenshot of a car going from dual wire mode to single wire mode on a CAN-B system. Where both sides mirror each other. But most of these systems, if I lose either high or low, I'm not talking. If I have an open, I may be able to talk past the open on the other side or get part of the message through. If it's a short, I'm probably not talking. So it kind of depends on the type of fault. So not all faults are equal. Hey, lady, get over here. Lady. Come here. Yeah, you get over here. Quiet. Odie, knock it off. The other thing we have is, do I have dual single wire networks or is it a dual wire network? And that's really hard to tell looking at the schematic. And we see this with Chrysler SCI. We see this with some other ones, Nissan. So there's a lot of networks that appear to be two wires, because if I look at them on the wiring schematic, there's two wires there, but they're not doing this. They're doing this, like north and southbound lanes. So we're using one wire to send information, the other wire to receive information. So if I'm looking at a wiring schematic, it's a two-wire network. But if I look at the language that's being used, it's two single wire networks, one in each direction. So they're completely independent of each other. So if I lose the northbound lane, guess what? I can receive messages, but I can't send any. Or lose the southbound, now I can send messages, but I can't receive them. So don't assume that just because you have two wires, even if it says that it's CAN, first of all, and second of all, even if it is CAN, don't assume if it's not connected to the DLC that it works like the CAN at the DLC does. So dual wire network or single wire parallel legs. Another network configuration often mistaken is called dual wire, passes through a module in a ring. So this is where we daisy chain a single wire network, where I have two wires going to the module, but we're connecting this module to this module, then this module to this module, then this module to this module in series. Daisy chaining. Single wire network, single wire communication, but we're plugging this module in, then going to the next module. Like those Christmas tree lights we had as a kid. So it's a series circuit.
So if one goes down, they all go down.
Everything past that point can go down unless we daisy chain all the way back around to the first module.
So daisy chain ring.
Right. You got it. And that's very common. The daisy chain is very common, and that's helpful because if I lost communication to three modules and I look at the wiring schematic and the three modules, this module, the one that's daisy chained after, and the one that's daisy chained after to the end of the chain, I can't talk to the three. Where's my problem? It's the wiring between the module I can't talk to and the one I can, or that module itself. So, and I got some pictures coming up, so if you guys aren't following me, but yeah, so that's why it's really important to know, how did they build it? What's the physical structure? What rules does it have to follow? Can it talk in both directions? I got a single wire, but can I only talk counterclockwise, or can I talk clockwise and counterclockwise? That's going to depend on the protocol. What are the rules? Right? So just because I can draw a pencil back both ways or a highlighter both ways, am I allowed to talk both ways? Getting harder, not easier, huh? So to become a node on a single wire ring network, a module must be able to detect messages, send messages, and let others pass through, usually in both directions. To become a node on a single wire ring network, a module must be able to detect messages, send messages, and let others pass through, usually in both directions. The end result is a wiring diagram that shows two network connections to each module, but they have the same information. They're not mirrored. In other words, I don't have a mirror image of the information. We're just taking message in and we're sending message out, and maybe I'm adding something to it, or maybe I'm not, just looking to say, do I need to know that? So this is like being in a room with a bunch of people and someone says something. Well, I hear it. Do I need to do anything about it? No, they didn't call my name. I'm ignoring it. Or I'm pretending to ignore it. So network to construction. So here's the different terms: series, series loop, parallel. So modules connected a line, often called daisy chained. Lens are a good example. This is not a parallel network where we are just jumping them one at a time. We also have a series loop. This is where modules connect in a line, but the ends connect to form a circle, also called a ring network. And then a parallel network. This is where each module has its own leg from a central location. And these are great for diagnostic testing. Parallel networks are some of the easiest to diagnose because there's a central point where all the modules plug into. And so then if I think I have a short or something like that, I can go to that central point. I can unplug stuff. I can test each of the legs as I pull all the modules out like I would on a daisy chain system. So each of these has advantages and disadvantages. You know, on a parallel system, if I have a short in the network, it takes the entire network down. If I'm daisy chained in a series network, it's only going to take out stuff past that point or potentially just between those two modules down. So again, one's more resilient than the other, even though these could both be single wire networks or 2-wire networks. We build 2-wire networks in all these ways also. So this is not exclusive to single wire. We have series 2-wire networks, series loop 2-wire networks, and parallel 2-wire networks, just like we do this with single wire networks. So we can use the same construction technique regardless of how many wires we're using. So series topography, in this case, I have a DLC. It goes to the PCM and then it goes to the TCM. So here there's 2 wires connected to the PCM, but it's a single wire network. It's getting, if I want to talk to the from the DLC to the TCM, I'm actually going through the PCM. So if my TCM stopped working, I'd still talk to the PCM. But if the PCM stopped working, I'm probably not talking to anybody. So this allows me to kind of focus on what are the possibilities. If I could talk to the PCM but not the TCM, that means either the TCM is bad or the wire between the PCM and TCM is bad. So what do I need to do? Go to the TCM, hook up a lab scope, check for a network signal, and check for powers and grounds. If I have a network signal, powers and grounds, I need a TCM. If I have powers and grounds and no network signal, I have a bad wire. Time to check the wire between the PCM and TCM.
Or how about output from the PCM?
Could be. So I need to double check that too.
So you just check continuity on the wire and then see if you get something.
Yeah, I usually use a lab scope, and what we'll actually do, and I got this coming up, I'll use 2 channels of the lab scope, one at the TCM, one at the PCM.
Okay.
Is the signal the same? It should be. It's supposed to be electrically the same. So let me hook up multiple test points, because if I have high resistance in the network, I may still have a signal to the TCM, but it might not be anything the TCM recognizes or will respond to. So therefore, let me see if it's the same both places. That's the advantage of having multiple channels on a scope, is we can do that comparison between 2 points in the same circuit or multiple points in the same circuit. And that's the best way to find resistance, because we flow so little current through here, your ohm meter is not going to pick up something that's going to cause a problem. Your ohm meter doesn't push enough. I mean, yeah, if it's open, it's going to find it, but what if it's just got high resistance interfering with the signal? That, yeah, I've got some noise on my scope, but is it noise that the computer's going to recognize? And this goes back to where we really just need to shift instead of, plus the other advantage is I don't need to unplug anything to use a scope, where if I'm using an ohm meter, I got to unplug both ends and do all that. So here's another, here's a daisy chained example here. This happens to be a FlexRay system. So this is kind of a combination of systems, and that I have a central gateway with one, let me get over to it. 1, 2, 3, 4 networks going to this gateway, but then I have these intermediate modules that are daisy chained in the middle. So this network is daisy chained, This one gets its own network to this module. So you can see where with this structure, again, it's real important to look at the schematic, who's talking, who's not talking. Because if I can talk to the J533 module here, which is the master module, who else can I talk to? So this, can I talk to nobody? I'm thinking maybe my J533 is having an issue. But if I can talk to everybody here, everybody here, everybody here, but I can't talk to these two, that's just a network problem with that daisy chain setup. So you see where, you know, looking at that, a wiring can really help. Here is a looped series. So here I have from the DLC to the HVAC, and from the HVAC, we go to the cluster memory seat radio. So if the wire broke between the memory seat module and the cluster, I'd still be able to talk to everybody, but I'd have a network code, most likely, set by either the cluster or the memory seat module or both.
Would it be
Because they're
basically,
identifying that that wire's not working, so they're setting a code, but yet I can still talk to everybody because they're able to communicate back through the radio and the HVAC.
does it have the type of software like a comprehensive component opens and shorts?
Yeah, a lot of times network systems do. So a lot of the codes we get are those open short codes. We got to be careful though, as we'll see coming up, because sometimes those codes could be misleading. And I got a case study coming up kind of illustrating that to expand that a little bit more. Nothing is just simple and straightforward. You know that.
Right.
What fun would that be? So here's a splice star parallel. Star networks are easier to identify in the wiring diagram. Individual legs project from a central junction to each module. So GM does this. They use a comb on their class 2, but Toyota, BMW, others also do this where they run to a central splice point and then everyone goes out from there. So Toyota does this with their CAN networks. It's just 2 wires on each of these legs instead of 1. So don't think of this as a wiring schematic. Think of this as a, you know, network schematic. This is how we built the network. Whether it's 1 wire or 2 wire, the framework is the same.
So there is no gateway module on that one.
No gateway module. We're talking to everybody individually. So if I can't talk to the IPC, time to go talk to time to go look at the IPC.
So
Right.
basically, look like they go to the hub or
Yeah.
some
Right, but the
splice.
hubs, I mean, if the hub's easier to go to, why not?
Yeah.
But if it's the same effort, I might as well go to the IPC. So a lot of it, you're right. It's about where am I going to go? Whatever's easiest. Right? Because, you know, if I have a test point I can get to in 5 minutes and a module takes me an hour, I'm going to go check to that test point. At least I'm going to get some of the information. And maybe that's enough to justify going back to the customer to get more money to dig out that other part. As we've proved the junction's not the problem. So in this case, everything but the PCM and ABS are offline. Why? So here we're looking at a schematic and we would have to trace through and see, wait a minute, I can talk to the PCM, I could talk to the ABS. Why can't I talk to anything else? And so as we walk through the process, where's the problem have to be? So I can talk to, so first thing we want to do is find our communication, right? So what am I communicating on? I'm communicating on pin 2, class 2 data. And what can I talk to? I can talk to ABS and PCM, right? But I can't talk to anybody else. So where's the problem have to be? It has to be somewhere between my splice 126 and what is it, splice 201 there?
Mhm.
So do I want to try to find splice 126? Do I want to try to find 201? Where do I want to go? And again, that's going to be based on accessibility. I don't know, when was the last time you guys tried to find a splice in a harness? It's not fun. Because they're usually only within about 3 feet of where they tell you. So there is some component location, but they are hard to find even with the component locator. But that's where the problem has to be. So I would probably go to the splice 126, verify that splice is good at that point, because that's probably easier to get to than 201, which is under the dash. And if 126 is good, now it justifies what? Getting more labor to get underneath the dash and start tearing into 201. If the 201 splice is good, then I've got a bad wire between the two.
How do you even bill that out? You can't do time and material.
Nope. So what I have to do is look at where it is and figure out what it's worth. What is it worth for me to get upside down on my back
Absolutely.
and go to the next step? And you know what? I'm thinking that looks like 4 hours. So now it's, do you want to pay? Is the fixing this problem worth another 4 hours? Or not fixing it, finding the problem worth another 4 hours?
That's all fair enough.
So now I'm flat rating it. I'm doing a brake job. If I get it done in 1 or 2, I've made money. If things go bad, it takes me 6 to get to the next point. I've lost money. So like on something like this, I got the 106. My next stop is 201. Once I get to 201, I have a diagnosis, right? It's either the wire or it's a splice. Once I'm at 201, it's a diagnosis. Now I can go back and actually get the labor to either replace the wire or find the broken wire there that goes between the two splices. So I'm probably going to step this in a couple things. So I got my initial hour. Now I'm going to get however much time I need to get to 201 and do my tests. Plus, once I get to 201, could I use a jumper wire from splice 106 to splice 201 to see if I can talk to everybody?
Oh, yeah.
Yeah. So let me hook up a jumper wire to prove that now I can talk to everybody, so I know 100% when I find and fix this wiring problem, this thing's going to be fixed. Now I can kind of double down on the labor, can't I? Right? Because now we're talking the repair, aren't we?
Yeah.
So I've got my initial hour diagnosis. I've got my 1 or 2, whatever I need to get to 201. I've got my final diagnosis. I know this thing's going to be fixed when I'm done. Now I'm into how much is it to trace and fix a wire?
But Brian, according to this the wire diagram, if we talk to everybody, why we have to go to 201?
Why do we have to go to 201?
Yeah, because they talk to everybody except PCM and ABS only.
No,
So
everybody but PCM and ABS offline. I can only talk to the PCM and the ABS module.
Oh, okay, got it. Got
Yeah,
it.
everybody else is offline.
Oh, okay, got it. Sorry.
Yeah, no worries. If I'm not being clear, always back me up. You
No,
know
it's,
that.
yeah, it's
So that's
Well,
why we're looking at this wire between these two. So these are 2 good test points. Then go down the rabbit hole. Once I prove this is wrong, now I can get the labor to cut open a harsh trace a wire or run another wire, whatever I need to do. And I have the added benefit of knowing that this is going to fix the car. Well, so wait a minute. This car only talks to 2 modules. Nothing else works. What's that worth to fix? Is that worth $500 to fix that car? Is it worth
I'd
$600
pass.
to fix that car? Right?
1,000.
$1,000 to fix the car. We need to get out of our head. Gee, it only took me the 3 hours, right? It's what's the value of the repair and what technical tools and expertise and how many hours did you have to spend listening to Brian to be able to fix the car?
Yep. What about that the door panel down low that just digs in your back, dude?
Yeah. Or the fact is you get older, I can't see underneath the dash. There's not enough light and I can't get far enough away for my glasses to work. So, there's all kinds of problems there. But the point being is that, we can't just flat off go, oh, it's huge. And then we need to walk the customer through the process and we need to be fair to the customer. And it's all based on accessibility. Is 201 easy to get? Or do you need to take the dash out to get to 201? All of a sudden 201 is going to get a lot more expensive to do that next test, isn't it? So it's really important that we do our research when we're doing network problems. Can keep in mind, network problems, no one wants to do them.
So Ryan, do we need to specific, special wire if we had a wire problem, to connect to that 2 point, or just regular wire?
Just regular wire.
Okay.
Yeah.
Sometimes we don't need to pull the whole harness, to find where the cut is,
Exactly.
So do we need to find the wire with the special material or just a regular wire?
Regular wire. This isn't shielded. This is regular wire on this one. And one of the tricks I use is, even though this is a solid wire, where does it go? If there's an easily accessible spot to the harness in between these 2 points, I'll cut the harness open there, look for that wire, find it, and then cut the wire there, or test the wire from there. So I'm not cutting open the whole harness. Let me get to the middle of the harness. Do we have something here? Divide and conquer. That's not always possible, but it sure can be, starting at one end and working your way to the other. So there's not a single, and what's not illustrated here that we know it has to do, it has to go through a bulkhead connector. Because splice 106 is under the hood and 201's underneath the dash. The bulkhead connector is not shown on this schematic. And part of that's because this is an aftermarket schematic. So maybe I need to go find the factory schematic now. It's going to give me the pin on the bulkhead connector. You see where I'm going with this? You see why the research part is so important? And we need to ask questions. No one runs a wire from the outside. I shouldn't say no one. Most manufacturers don't run a wire from the outside of the car to the inside of the car through a harness without going through a bulkhead connector. Some do, but it's certainly worth doing a little bit of research to see if this is actually a hard wire or if there's a bulkhead connector here. I mean, Toyota put their computers inside, so I can't say all. But certainly not everything is shown on all schematics. You guys know that. So we should always be looking at aftermarket and factory schematics to try to get the best picture. Network splicing, we kind of talked about this before. Do they need to be soldered? Well, here the manufacturer says no. So these ones are crimped, and this is Audi. So Audi crimped and heat shrinked. Do other manufacturers solder? Absolutely. So there, we don't have a hard rule one way or the other of it won't work unless you do the following. And that's why I kind of leave it open to what are you good at? What are you comfortable with? I crimp a lot of stuff. Okay, it's going to depend on how many wires. Do you want to crimp and solder? I mean, the whole idea is don't put extra resistance in the circuit. So whatever you do, do it well. So here is a multiple loop example. And one of the things that's really helpful is getting out the highlighters and tracing to see how things flow. And I'm going to do this a couple of different ways. There's not one right way or one wrong way. And you'll see there's more than one way we can do this. But the idea is to understand how information is processed. So down here at the lower right, I have pin 2 for the DLC. It goes to a splice, and then it's going to go through my different networks. So you see I highlighted in purple where I'm going from here back to here by tracing through the network. And we can see how we daisy chained here. All the way through this all daisy chain. But if you notice, we're not talking to these modules. That's on a different part of the network. So even though this is all the same language, not all modules are in all loops. So let me get the highlighter out. Here's another daisy chain loop. You can see my green now. So it's coming back over to that splice. Here's my little red loop I put in there. Again, these 2 modules. Here's a gold loop. Another daisy chain loop. And another red loop. So we can kind of draw these a couple of different ways to see how things are daisy chained to try to figure out what could be at fault and what can't be at fault. You see kind of how I did that? So there's not one way. The idea is, how is information getting shared? How is it getting transmitted? And then how does this relate to either what codes I have or which modules I can't communicate with? And by doing this, now we can localize it down to where here's where my fault should be. Here's the wire that's probably bad. But keep in mind, because I can go multiple ways, by the time the car actually comes in, for example, I have a broken wire right here. How's this going to affect my network? Well, I'm going to get probably a network code, but everyone's going to talk until we get what? Another break in the network. As soon as I get the second break in the network, now I have modules that are offline. So me being a technician, I go in, hey, I found a problem and it now talks. But I've still got this network code, probably because we only fixed one of the breaks, but now everyone can talk.
So would you send that? Would you be comfortable with sending that if they didn't want to pay the money? Your name stamped on it.
In the past, I always did because I didn't understand why. Now that I understand why, no, I would not. Because the redundancy is out of the system. Yep, I got everything working. Now we need to fix the other code. And that's why you should always sell a diagnosis or repair of, retest for proper operation when completed, right? Your repair should always be retest for proper operation, because I may have a working system, but still have a code. Maybe I give the choice to the customer and say, hey, look, you still have a problem. Maybe the customer doesn't have the money. Maybe the customer can't afford it. The car now runs, it works. They've just lost their redundancy. If they're willing to roll the dice, they can do that. But I want to make sure they know they're rolling the dice, and not that, oh, I fixed it, and now when the next thing goes bad, there's no redundancy and I get it back on a tow truck.
Right.
I have no problem
That's what I
shipping
don't
it.
want.
Exactly. I have no problem shipping it as long as the customer owns the decision. It's their decision. I mean, we do that all the time. Do we replace the whole wiring harness, or do we open it up, repair the wire, or do we run a wire down the outside of the harness? Well, that needs to be what? A customer decision, because what are the odds there's only one damaged wire in the harness? Pretty slim. But we all have customers that don't have the money to fix it right. So how can we take care of the customer and still protect ourselves from liability?
So
And
document it.
What's that?
Document it. Document it.
Yep.
When you
We
talk to
always
the customer.
recommend doing it the right way.
Yeah.
But
Or
yeah, we
you can
understand
say,
some of our
further diagnosis if need, after we do such and such,
Yep. Absolutely. So, boy, the last hour went quick. I will see everyone back at 10:10.
All right.
Come on. Come on. All right. Perfect time. Need more parts. Okay, so here's our star. I'm still missing quite a few bodies. Let me get one in here.
Yeah, I'm here.
All right. Okay, so our star parallels network. This is GM's class 2. BMW, Mercedes do this. Toyota does this. Quite a few manufacturers do. The splice pack here is GM. So this is the picture you're looking at is a single wire network, GM class 2. We do the same type of construction with 2-wire networks. The advantage of this is that you have a great central test point. So many times these junctions or combs are easy to get to. Also, they're not hard spliced, so you can individually unplug things for testing.
You can.
What's that?
You really can unplug.
Yes. Depending on the system. Some are unplugged, some like GM, you take the comb out of the back, which gets rid of the jumper. So now everything's on jumper, then you can jumper stuff individually to test. So they are a little different, but like Toyota just plugs in. It's just got a little detent. You push it down and pull it out for each module. So really, 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 really nice. But if you have a network problem and it's a star parallel network, you kind of hit the home run, because these are the easiest to isolate all the modules, because you just got to get to one point and then you can isolate out where the problem is. If I'm not communicating and I have a shorted network, you pull the comb out and then you can see which leg is shorted. I mean, so you, again, from a diagnostic standpoint, this is kind of the home run model. So here's a splice connector schematic. So this is the same thing except for an actual schematic. We would remove the splice and then diagnose each leg of the network. Or if it's a Toyota that I'll show you on the next page, you can unplug each leg. But same concept. So this allows me to isolate all the modules that are connected to the splice at one time and then test those network legs individually. So here is Toyota at the top. This is what I was talking about, Daniel, where you can individually unplug them.
Oh wow, I haven't
So-
seen that.
Yeah, and that's Toyota Can. I mean, so that's really nice. They use a couple of these in the system. Some are easier to get to than others. Below that, we see BMW and Mercedes. You can see the Mercedes system. Again, 2-wire network, very similar to what Toyota's doing. BMW's looks a little more old school there, but same
Right.
concept. But again, what's easier, digging out 6 modules, 8 modules, or one of these? So that's why it's really important, aside from the code scan that we're going to walk through and the other side we're going to walk through, but that the part that technicians skip the most is the research, right? They feel like they're losing money if they actually look something up. Like somehow I'm going to go tear apart the car and look for it because
I kind of want to disagree because I work for a few. The management doesn't want to pay that half hour,
right.
nor do they want to pay for Mitchell or All Data or for like IDS or something. Like they always think it's an under the hood problem. It's the culture of the leadership, I think.
Right, and that's because they haven't been to. If they used to be techs, they probably haven't been a tech in 20 years or 30 years.
Yeah. No, absolutely, 20, 30 years.
So, and I mean, I ran into that in the 80s when the shop owner hadn't turned wrenches since the 60s, and his philosophy on how I should be fixing things was very different than how cars work because he hadn't done that. So many shop owners don't stay up technically. Some do. I always have shop owners in this class. I know shop owners that even if they're not doing it every day, are really involved. They go to workshops, they go to stuff because they know that, hey, at the end of the day, the car has to be fixed. And B, they want to be able to really help not so much do the repair, but guide their tech through doing the repair and give other diagnostic options or really work in that support role. So there are owners that are really, really good and really, really technical. There are other owners, and those are usually the owners that you have Mitchell, Identifix,
Right.
All Data, IATN, everything there, and every technician has their own terminal because I understand that if you have 2 technicians that have to share one computer, productivity goes down.
Yeah, and
They
that's a problem.
understand the value of that. You have other shops that there's one computer, it's in the office, and the techs aren't allowed to use it. And I've seen both extremes. A lot of shops are somewhere in the middle. But, there's also something to be said for telling the owner they're wrong and this is what we're doing. Hey, you laugh. I did that to a guy I still know. His son owns the shop now, big import shop, huge import shop. And it was an old CIS car failing smog. And I got the car overnight and got 2 hours to do a fuel pressure test on it. He goes, what are you wasting your time? Just turn the 3mm Allen, make the car pass smog. You're wasting time. Well, guess what? We did it my way. Found a bad warm-up regulator, put the $800 warm-up regulator on the car, never had to adjust the 3mm Allen, and the thing blew almost zeros out the tailpipe. So instead of a half-hour adjustment and a kick, it was like a $1,200 ticket. And this was back in 2000. And I got to take my hat off to him. He came up to me the next day and he says, I've been working on these cars for 20 years. And he still did a lot of stuff himself. He goes, you showed me I've been doing it wrong for 20 years. Thanks for sticking to your guns and you taught me something. And so that meant a lot to me, having an owner that I respected who really, had taken this shop from nothing and built a huge shop out of it. And was a smart guy and really knew, especially this old Euro stuff, to come up to me and go, you know what? You showed me I've been doing it wrong. And so I think sometimes we just need to have the conviction that as technicians, we are the expert. We are the doctor. We do know the right way to do it. And I've had shop owners go, hey, what do you do? Stop screwing off on the computer. The car's over there. Customer's in a hurry. Well, I know
I get
I'll
that all the
fix it
time.
up here before I can fix it with these. And I am working on the car. Let me do it my way. Do you want to fix the car? I'll go do a brake job.
Yeah, I know. They make more money probably too.
Right, exactly. Really, you're so smart. You want to fix it? I'll go do something else. I don't have an ego. You can fix it. I'll go do easy stuff.
Yeah.
Assign me to the dumb stuff. I'll go do that. I mean, you can take the network problem, give me the oil changes, I'll still make the same money at the end of the day, because what do you think those oil changes need for something, maybe?
Absolutely.
Right.
Yeah.
So, I mean, I don't have any ego in it. You don't want me to do this job, I'll go do something else. But if I'm doing this job, I'm doing it my way, because when I'm wrong, I'm the one that has to burn. If I do it your way and I burn, now I'm just pissed.
Hey Brian, what the benefit of this class? Apply for the guy only do the test. Nothing.
Oh, a guy who only does the test only? I think that it really applies in that understanding that network problems and how things are related. So it does twofold. One, you can better advise the customer as far as going to get it tested and the shop to, get it tested. The other is when the car comes back and maybe they're trying to get a cost waiver or something like that, it's a directed vehicle. And you're looking at the paperwork and thinking, man, wait a minute, this doesn't make sense. Why would this have anything to do with that? This is going to help understand that, yeah, the part in back might not be working because the part up front's no good. So some of those kinds of things.
Well, don't. If I do the test only, I don't need to understand all this, right?
No, you don't. And that's why a lot of the test only guys don't have a repair license.
Got it.
But if you have a repair license, even if you're only doing test only, you should do it. But I think
Is that the EI number, right?
What's
Is
that?
that the EI number, right? EI license, right?
What EI is repair, yeah.
Yeah, EO the inspector, right?
Right. Because it made too much sense to have EI be inspector.
The test only they had to go through this class?
What's that?
The test only they had to go through this class?
Not if they don't have a repair license.
If they don't need the EI number.
Yeah. So this is a repair class. Now, me, I think that knowledge is power. So even if you're not doing the repairs, having the conversation to be able to understand, or when they go to their favorite mechanic and they kick it back to know that their favorite mechanic doesn't know what they're doing and advise the customer that they need to go to a smog check repair station that can actually fix it. I think there's some advantages to that. So here's a noted parallel. So here, very similar to the last, except for a splice in the middle, we have a gateway module that's talking to everybody. So there's our star system.
Take the gateway module. Why don't we just go to the hub or to the slide?
Because the engineers like messing with you.
Okay. Fair enough.
Hey, when I'm king, we build them differently, okay?
Why they add another module in between those guys and it create all kind of weird stuff.
Yeah, sometimes it has to do with the protocol. Certainly, we're talking these modules. There's no reason to do it. But if this was a LIN system and my gateway was the IPC and I'm talking to all the steering wheel switches, then that's the protocol of the system. So I have to use a gateway. And so it really kind of comes down to, sometimes what protocol. So even though we're using here in this illustration, module names that everyone recognizes for simplicity, we probably wouldn't ever use this system for these modules.
Brian,
Yeah.
can I cut you off? I'm sorry. My wife's water just broke. I got to run to the hospital.
Okay. Congratulations.
Thank you.
Make sure you tell her what bad timing it is, huh, Tony?
Yeah, very bad timing. She went for soccer practice with my daughter. She feels I'll be back if anything changes, but according to her water broke. So
Hey, congratulations. Take care of the family. Tony, send me an email.
thank you, man. Appreciate it.
You bet.
Goodbye.
Well, it's exciting, huh?
What a day.
Yeah. It's been 28 years, 29 years since I had to deal with any of that. So
I mean, you between gateway module and the hub and
Well, a
the
hub-
slide,
right.
it's okay. Make the people confusing too much. It's so many terms.
Right.
To understand the network.
Right. Well, a hub just is a connection point where a gateway actually controls the flow of information.
Basically, they
So-
translate the language.
Yeah. And controls it. Right.
Okay.
So if we're going to translate I don't care from what language to English or English to whatever language, it's not a direct translation, is it? It's an interpreted, or it's kind of reformulated because different languages have different ways of speaking. So there's always something where they say lost in translation, or where the interpreter might use a different word or something, which might actually change the meaning slightly. That's interpreting as opposed
So
to.
must be very, very important, module. So must be very necessary to design that module.
Right. I go with manufacturers don't want to spend any more money than they have to. So if they're using a gateway module, there's a reason. If they're
Right.
using a hub, there's a reason. Because the manufacturers, even if they can save 10 cents on every car and they make 1 million cars, that's $100,000, right?
Right.
So, I mean, and that's how they run car companies. I mean, they're down looking at how can we save a few pennies because it's exponential. So, that 10 cents doesn't matter or pennies don't matter. It does when you do it 1 million times.
So how did the vehicle run with the gateway module go bad? So
Okay. So it depends on where the gateway module is and who's using it.
because
So,
this it seems like the central universal, they
right.
connect
So
everybody together.
it links everyone together, but does my powertrain module know how to control the engine? Maybe. Does he really need to talk to anybody else, or can he just operate the engine and go, you know what? I don't know these things, so I'm going to use these sensors as higher priority and make the best choices I can.
But how they know how fast the car go? They had to look on the speed sensor.
Right,
know?
but do I need to know how fast the car goes to run the engine? We didn't in the 80s. We didn't in the 90s,
I know.
right?
So they
now
will
our
default to
computers-
default move, to self control.
Right, exactly. Did we
Okay.
do as good a job in the 80s as we do now? No, of course not. But did the car still run? Yeah. So we go to this backup programming where I don't need to know how fast I'm going. I don't need to know this. I don't need to know that. I can still make the engine run.
All right.
We're just going to run off our load sensor and make the best choices we can. And I got my O2 sensors, and here we go. And
Understand.
maybe we're going to get 20 miles a gallon instead of 25 miles a gallon, whatever. We're still getting there.
Okay.
So these configurations are built using, so the RPO codes, these are GM's regular production option code. This is how GM lets you know you have options. So options might equate to which modules the car equipped with. And therefore you'll see these RPO numbers down in the wiring schematic. And these are these little square boxes we see down here in the schematic are these RPO codes letting us know, hey, this is equipped, this is not equipped. So not all cars have all modules. So this is a way on GM of verifying whether or not that module is actually supposed to be on the car or not. So sometimes you'll have someone buy a car, especially secondhand, that thinks something should be there that guess what? That car never left the factory with. So they're bringing it in to get something fixed that doesn't exist. I remember back in the days, I'd have customers come in and complain their intermittent wipers didn't work. Well, you bought a car without intermittent wipers.
That's hard to explain.
Yes.
You can't fix broken, man.
No, you can't fix stupid either.
Well, yeah, I was gonna say that, but it's trying to be political correct.
Since when do we do that in the auto business, Dan?
I don't know. I'm on Zoom. I don't know who's watching.
Okay, so scan tool use. So here I'm using a console 3 and we're looking at the Diag CAN network. So what the console does is it kind of gives me the topography for each of the different networks that I'm able to talk to. So this topography doesn't match the actual wiring as well as some other manufacturers' versions, but it still helps. In this case, we know the TCM has a code and that there's other modules, the PSB and ICC, whatever they are, aren't on this vehicle. It's not equipped with it. So, but I can kind of see where, so if I looked at this and I saw 4 modules or 2 modules going to that same connection point not working, guess what? I got a problem up at the connection point or somewhere in there. But if it's just one module that's not working, like here, or one module has a code, again, so this is Nissan's version. Not quite as fancy as Chrysler's, which shows all the stuff. So this is the main screen of the tool. This is Chrysler. And it shows us that we have CAN C and CAN IHS. CAN IHS is everything to the right and CAN C is everything on the left, 2 different speed cans. And we can see we have several modules that are able to communicate on both networks. Then I have BMW ISTA, which is BMW's factory scan tool. They have a couple different screens they use. This is one of them. And this shows the gateway and multiple networks. Again, each of our networks has a different color. And the modules being shown in different colors means there's different things going on with the module. So does it have a code? Does it have a problem? The ones in gray are not on this car. So I need to go to the decoder for this tool and say, what does that color mean?
Well, what denotes gateway?
The fact that both of these go to the combi module.
That's it. That's how you.
It.
Okay.
That's it. Right? Definition of a gateway, a module that's on 2 networks. And that's why I broke that down to just a real basic, this is it. Module on 2 networks, done.
What
So
that
here's
module?
What's
What that
that?
module? What that module in the middle?
Yeah, in the middle, the combi module.
What does combi mean?
Great question, don't know. Not important right now. I probably have it in notes somewhere, maybe not. No, actually, I don't.
UFO module, huh?
Yeah. AOMBI modules. So if I have a BMW guy in here, he can tell me. But in this example, it's the JBE module that's the gateway. So you can see where it is, and it's talking to 3 different networks and how they broke the networks down. So I really think that as handy as this is going to be for diagnostics, and we're seeing more manufacturers put it in their factory scan tool. What do you think? 5 years before we might start seeing it in some aftermarket stuff?
I mean, that would be not. You'd probably have to pay extra.
Yeah, or it'll be the latest bell and whistle to get you to buy that $1,200 update for your $10,000 scan tool or $15,000 scan tool. So. And the key point in here is never assume who the gateway is. You got to look at the system. Even though we're on the same manufacturer, both of these are BMW, 2 different gateway modules. Now,
what's this
used normally? Who does this manufacturer normally use for gateway? Like GM normally uses a BCM as gateway. Does that mean it's always the gateway? No. So wake up circuits. I mentioned this a little bit earlier. For some networks, ignition power is all it takes to wake everybody up. Time to go to work. For others, there's a power mode master module which wakes up and starts talking. The network traffic wakes up all the connected modules. So that's normally our master module. Lastly, some networks have an extra circuit that applies voltage to the modules in the network to wake them up. So this is a parallel circuit to the network that's sending out a voltage impulse saying, hey, time to go to work, you're getting traffic.
Well, who's telling this parallel circuit to apply voltage?
And it's going to be a master module. Good question.
So if there's an issue with that power wire, then that could also be a communication problem.
Right. So if I have a network that uses an external wake up, even if I have power to the module and I have network communication to the module is never going to talk because it was never woken up.
So we need to know the way the network's configured, just specifically for that reason.
Right. And the manufacturers that do this also need send some neat codes where, because it sends a wake up signal and then it doesn't see the module. So the master module's doing both things, right? It's sending out a wake up signal and say, hey, I called him and he didn't pick up the phone. And so now the question is the wire broken in the network, in the wake up signal? Is the module bad and doesn't understand what a wake up signal is anymore, or what's going on? But yeah, that is something to keep in mind on some of these networks, especially once we get out of CAN, or at least high speed CAN that our powertrain's running on, because this is more common there. And again, you think about how frustrating it is. You put a new module in, you did your due diligence, you checked power and ground, you checked for a lab scope waveform on the network. We can see network traffic, put a new module in and it still doesn't work. You can't even version code it. It won't even talk. What's going on?
Well, then that's
Someone's
why
picking it up.
sometimes struggle with like Mitchell or Protoman, because they give you wrong information and now you're diagnosing with wrong information, and then you think you're on the right track when you're totally wrong.
Right. I personally prefer all data.
Yeah, good to have them both.
Yeah, I mean, we have both at the shop, and occasionally something will be on Mitchell that's not on all data, but all data is usually my first stop. And the thing I like best about all data is the factory schematics, because I've been burned many times on Mitchell's aftermarket ones.
Yeah.
I
The
think
other
identifies they use all data, right?
Yeah. The other is that all data tends to go in and give you the enable criteria. This is what the computer saw to set the code, and then give you a flow chart. Mitchell tends to just go in, follow these steps and replace a part. Well, why am I following these steps? What did the computer see? I don't want to do these 20 steps. I'm lazy. Why is the computer mad? And Mitchell
Not lazy,
tends
smart.
not to tell you that.
It's not lazy, that's smart.
Yeah.
You know?
No, absolutely. If I know why the computer's mad, why did it set a code? If I can get that and a wiring schematic, I can figure the thing out. I don't need a flow chart.
Yeah.
Right? If I know, hey, the computer set a code because on this wire, when it turned this on, the voltage was over 5 volts for more than 15 seconds. Bingo. Now I know what I'm looking for. I'm not looking for a spike. I'm not looking for something that happens for 200 milliseconds. Whatever happened under this situation happened for a long period of time, and this is when it happened. Let me go test for that. That's what I like about getting enable criteria compared to disconnect, start oming things out. Why am I doing that? I don't want to, but why? Why is the computer upset? And that's why flowcharts really don't work well. We looked at one of the transmission class I did yesterday, and the flow chart's a solenoid code, and nowhere in the flow chart does it have you check the wiring from the computer to the solenoid. It has you pull the solenoid out of the transmission, test it. If it tests good, put a transmission in it. But nowhere in the flow chart does it have you check the wiring between the computer and the transmission, or even for a signal.
What is this transmission class you're talking? Who's it through?
This one was one we did for a vendor in the Midwest, Garage Gurus. So we built some classes just for them to use, and I built a transmission class for them. So it's not one I'll get to teach, other than yesterday when I got to teach their instructors. So I did a 5-hour class teaching their instructors how to teach the class.
Oh, we're not privy to that stuff, huh?
No, it was interesting. Learned some stuff doing it, but yeah, there is. So I get to, I mean, just like I do some stuff for the bar, I do some other stuff. So I don't get to do all classes, all places. Sorry. I don't always own everything. So if I own it, then I can do something with it. I am doing an EVAP class in April, though, in San Diego in person. So
I'll be there.
got that coming up. Yeah. So I think it's like the 20 something in April.
Is it with ATG or is it with Susan Zucker?
ATG. So beat
Oh,
Heather
yeah.
up on it.
How do we find out about that or get a hold of you for that?
A couple of different ways. One is you can go on to the website. I'll put it in. And you can go on there and you can sign up to get on their list, and they'll send you an email when they have a class coming to the area that you're interested in. And and I just agreed to do a EVAP class end of April. That's how I know that one's coming.
Yeah.
So we did put a chart in here of network strengths and weaknesses. So it talks about the different, series, loop series, splice star parallel, junction star parallel, and node to star, and talks about strengths and weaknesses. So this is just kind of a good table. I'm not going to read it to you. I figure you guys are all able to read by now. But I did want to point it out that it is in the book. So, part of diagnosing a network is understanding how it's built. If I'm trying to diagnose a failure, I think it's important to know what its weaknesses are. The odds are that's where it failed. And it's certainly going to affect the characteristics of the failure. So all codes or health check. The numbers show the order in which the modules were queried and responded, but the tool skipped modules that never responded. So in this case, 11 modules responded, 10 of them passed with no faults. One module, the audio control unit, reported a code. The key point here is because this is an aftermarket scan tool, only the modules that are talking will be listed. So if you have a tool that's doing this health check or query test as an aftermarket scan tool, it's only going to show you the modules that it can talk to. So it may have a list of 30 modules that are possible on the car. It's going to try to talk to all 30. It's only going to show you the ones that it actually established communication with. And this can kind of be a problem, because what if the module I can't talk to my scan tool doesn't even show me it's there because I can't talk to it. And that's the module that controls the functions for the problem I'm having. Or gets the module that is having the problem the information it needs to work properly.
So would you still have a fault?
What's that?
Would you still have a fault code then, even if you can't talk to that module?
Yeah, you'd have a fault called probably from other modules that can't talk to it, we'd hope.
Okay.
Not always, but we'd hope.
How about if it just doesn't talk to it because the software in the aftermarket scan tool didn't have the ability, or there's nothing wrong with the module, it just couldn't talk to it.
That's possible too. And the point of this slide is to let you know that just because the module didn't show up on this list does not necessarily mean it's not on the car.
Or bad.
Or bad.
No, I think if it's bad, it will talk and it trigger the code, but when they don't list it, they don't show on the list though.
Right. But that's one of the disadvantages of using an aftermarket tool. If I'm using a factory scan tool, it knows what should be there and it knows what's optional. So it's going to give me a much better list, and I'm going to have an easier time finding if something is missing. So this is Toyota, not very many modules there, but it does tell me if they have codes. Here is Ford, and Ford is kind of neat. If you notice, we have the standard equipment modules. Hey, all of those should be there. And we have the optional equipment modules. Is this car supposed to have them or not?
It says fail.
Right. And it says fail because it's not there, but it's an optional module. Is it even supposed to have it? So it's just failing to communicate. It doesn't mean that anything's bad.
So you mean not able to diagnose the network code on the aftermarket scan tool?
Well, you can. You just need to ask more questions and maybe do more research.
Otherwise, it's gonna lead you to the wrong, you know.
Right. You might jump to the
Diagnosis.
wrong conclusion or you might miss
Conclusion.
something. We should be doing an all codes health check every time. You know, in the old days, we only talked to whatever module had the problem, PCM, TCM, ABS, whatever. We should now, regardless of which light's on, be doing a whole health check. And it does a couple things. First of all, it lets us know who we can talk to. It lets us know, it may let us know who we can't talk to. For example, I do a whole health check and there's no ABS module, but yet the car clearly has ABS. Clue, you know, so we do see things like that. The other is that other modules that the customer is not complaining about symptoms today may have problems. And customers are always much more sensitive to how their car works after
Nothing.
we work on it, right? Ever
Yeah.
since you worked on my car, it has this rattle. Now that's the rattle that drove you nuts on the test drive. You tried to get your service advisor to sell you some diagnostic time and the customer declined. And then they come back 5 minutes after they pick up the car saying the rattle was never there. Am I the only one that's ever happened to?
How about ever since you changed my tail light, I've had a flat tire.
Right. My favorite is I got a new idler arm and now my car doesn't idle. And I've actually had a customer do that.
What in your opinion to fair charge for the rattle noise or some kind of suspension noise? An hour, 2 hours?
Depending on, I'm usually a half hour to an hour.
Because it's pain in the butt to indicate. the
Oh,
noise.
absolutely. And some of them are easier than others. I have a noise in my car that I still don't know what it is.
Me too.
Yeah,
I have
me too.
my van on the back. I couldn't figure out what it is. My
Yeah,
own car.
I got a noise in my camera. I thought it was a bad strut bearing plate on the strut, and it's not. And, and it only happened after the car was in an accident. I've rechecked all the bushings. I rechecked everything. Everything's tight. I've retorqued everything, and I get a pop only when I turn in a certain way in the parking lot. And speaking of which, I don't think it's done for a little while. Maybe it finally fixed itself. But yeah, I mean, I spent some time trying to, you know, do I need struts? What is going on here? And I mean, we had it on the
It's still
liner
there.
rack going
It's
back
still
and
there.
forth. I've had stuff on it. It's like, I couldn't find it.
Yeah, it's just finding the noise not that easy, you know. So
No,
I
it's
just-
not.
yeah.
And I've also had cars where I fixed the really bad noise. Man, nailed it. The strut and rear shock broke. Man, that thing's banging away. Call the customer, sell them the shocks, put it on customer, picks it up, comes right back. My noise is still there. We go for a drive. It's a noise I can't even hear. That's the one they're upset about. It's like, you know, really? Turn up the radio.
Yeah. Yeah.
So here's a GM Tech 2, which GM used till 2013. And again, hey, DTC check. Which modules are here? Are they awake? Are they active? And I can see here the IPC is not active. And so in this case, it's because the screen constantly updates and it may refresh. So I need to wait and let it do that. But you can see this is one of 6 at the bottom. So it's where we at on the menu.
So the IPC not active.
Not at the moment, but give it a second. Maybe it's just asking it right now if it is active. So sometimes you got to wait because the screen's constantly updating. Is it going to come active?
Right.
But no, here it's not active. That gets my attention. Let me wait and see. And the biggest question, how's the car run? Do I have any problems with the IPC? Does the customer have any problems with the IPC? Well, then maybe it's just my scan tool. Maybe it's just the data it's seeing. This is Chrysler's factory scan tool. Not only does it have the active column that, hey, the module's there, has the added benefit of telling you not only which DTCs it has, but which network the module's on.
That's cool. That's big
Yeah,
time.
the YTEC's really a cool scan tool. It's just stupid money. So here's the Toyota bus check. Once you get the results, you need to continue refreshing it using the arrow button on the lower right to see if any modules have stopped responding. So unlike GM that constantly polls them to see if anyone stops working, Toyota, you got to push the button each time because the screen doesn't refresh on its own.
You ever run into the module not waking up fast enough to send a signal to the scan tool during interrogation?
No, I haven't.
Okay. I just wanted to know.
Not saying it can't happen, but I haven't seen it.
Well, sometimes I hit, connect, and then it says this, that, this is all bad, and you hit it again, and all of a sudden everything works. So
Oh, I have seen that where I'm not really
there's
talking
not
to
necessarily
anybody and
anything
then
bad.
talking to everybody where it's like a timeout in the scan tool. And that may
Yeah,
be
something like
something
that.
with the gateway where you're going through a gateway and it's not catching up as quick or it's expiring on the timer on the scan tool. I have had that where at first I'm getting like no communication, refresh, and now all of a sudden
Right.
someone's talking. I have had that.
Now everything works, and there's nothing wrong with that.
Yeah. Yeah, I have had that. I've just not had it with one module, but I have had it with everything.
Yes. That's what I mean.
Okay.
Yeah.
So GM has data bus diagnostic tool that's available separately from the scan tool, but it's actually kind of part of the same package. So what this does is it's actually able to measure the voltage at the DLC. So I can actually get a waveform like this. This is a capture from the same diagnostic tool based on the sensed voltage at the DLC. So this is more of a direct circuit check than a scan tool. So it's not quite what I see with a lab scope, but it's fairly close. And again, so it's really, and Ford's done something like this too with the new Ford scan tool where they built a scope into it. And it's a separate module from the scan tool. But this is GM. So they're able to run quite a few tests on the network through the DLC using basically a lab scope add-on to the scan tool.
I mean, that signal looks terrible. It just looks like a bunch of static.
It does. And like I said, that's why I say lab scope. But it may look terrible. However, is
It
it
should
in
tell
version
you-
from each other?
Consistent.
Yeah,
Yeah,
it should tell
consistent.
you, the network is working. Yeah, that's
Right.
nothing.
I have the correct bias and it mirrors each other.
Yeah, just needs to
That's
mirror each
what
other.
we're looking for.
Yeah, you're looking for the flag light. That means that it's dead. So
Yeah.
it moving, it's still working.
Right. And is the resolution what I get with a scope and see a square wave, which is what it is? No. But would this tell me if I had a problem on my high can, low can, or if it was shorted? Absolutely.
No, right?
Yeah, it was absolutely. It would show you that because I'm getting that function. So if I got a big problem, I'm going to see it here. But right now, it mirrors each other. It kind of, so this is more of a high level. Hey, it checks the boxes, right? It's mirrored. It looks even. It's doing the same thing. It has the right bias voltage. This is a normal communication, and this is a known good vehicle.
So what if it go bad? What are you gonna see? One flag light and one jumping?
Well, wait till I show you some bad ones, then you'll know.
Okay, got it.
So here Nissan on their factory scan tool does a network voltage test. So my high can normally goes from 2.5 to 3.5, and my low can goes from 2.5 to 1.5. If you notice, we do overshoot a little bit, both on the 3.5 and the 1.5 as it toggles. This is normal because we're sending that electrical signal out and coming back, we're getting some movement on it. So you're not going to see exactly that. This is a normal. But again, this is from sensing the voltage through the DLC connections, and it's displayed on the lower part of the scan tool here. So let me, if you get, where's my mouse? There we go. Come on. There we go. So the lower, so here's where these voltage numbers are coming from. So this is kind of slick. Again, this is a quick test. This is a function of the scan tool. Hey, who's here? Are the network voltages in the normal range? I mean, it's a time saver in a factory tool. So a lot of these factory tools are coming up with some really neat little things that, the aftermarket tools always are behind on, but I have to wonder how long is it before we start seeing some of these features?
Brian, what the benefit between CAN high and CAN low? Why don't they make the common the one in the middle?
Oh, because what they do is by doing this, it creates shielding for electromagnetic interference. So that's why they're inverted. That's why you see, the butterfly effect or this inversion here, because they're doing that because it creates shielding for the signal. The other thing it does is allows the computer, when it gets both of these signals, to see if there's a problem on one of the lines, because this is redundant information. We're sending the same information on CAN high as we are on CAN low. When it gets to the receiving module, it looks at both and go, do both the reports match?
So if it opens one wire, it will still pass the information through the other wire, the same information?
It will. And then the computer's going to say, I have a open in CAN low because I got a signal in CAN high and I got nothing in CAN low. Therefore, CAN low is open or CAN low is shorted, right? So that's why we're able to get some fairly specific codes, is because of this comparison. And so CAN is much more tolerant to opens than it is to shorts. I have some redundancy with an open. I have very little redundancy with a short. So that's why it really affects it. And that's why those codes we get matter. And that's why on newer vehicles, you'll actually see not just, hey, problem with CAN low or an open and CAN low, but you'll actually see it broken down between open or short, not just CAN low is open or shorted, which is what the early codes were. So we're seeing a lot better code definition. You may get both. You may get a code that says, hey, it's open or shorted, and then a second code that says it's shorted. Okay, so sometimes we get two codes for one fault.
What kind of code do we fix first, though? Communication code or the regular code?
Communication.
I would fix the one that's the most specific first.
Oh.
So sensors aren't sensors. So just because I have a sensor PID doesn't mean there's a sensor connected to the computer. So maybe that PID is coming from another computer through the data bus. Just like my controls, outputs. Is this an output from the module or is it a bus output where I'm actually asking another module? So if I'm on a GM and I want air conditioning, my climate control module is going to ask the engine control module to turn on the AC compressor, right? So my bidirectional control for the AC compressor is actually in my PCM, but all my requests and everything else are all in HVAC. So, and then my sensors, my inputs may also be coming from other places, not directly from that module. For example, IAT, or I'm sorry, outside air temperature sensor may be coming straight to my HVAC module, but it's shared with other systems. Or it may come straight to my instrument cluster and then shared with HVAC. Both modules may have a temperature PID. What's that?
What is this feedback sensor? The potentiometer and actual position PIDs are derived from an actual feedback sensor. What is this? A virtual software that's sending a signal inferred?
So
there's got to be a point of originality of something that produced this.
Yes, but
right?
on the other hand, sometimes you will see really inferred PID. So there is no sensor, but based on duty cycle, this is what a feedback would look like. Which is just kind of like, it's useless. So now you're chasing a sensor. Hey, wait a minute, there isn't one. So
could the computer simulate this value if there was an issue?
Yeah.
Could it just substitute a value, or could it?
Sure, it does that all the time. How do we get 40 degrees below zero out of an IAT?
Right. I get
So-
it. Right.
And also, some systems, if the sensor goes bad, right, give you that, hey, based on throttle percentage, this is the voltage that you should see on your scan tool, not the 0 volts or 5 volts because the sensor's broken. So, you see some weird stuff.
So
Really, the
so
point
the
of this-
feedback is just an extra signal that's tied in on a splice or something to a different module.
Not tied in a splice, shared over the network.
Software then.
Software.
It's zeros and ones sent out.
Zeros and
Okay.
ones. Just like our output. And this gets really confusing because there are some systems out there that the bidirectional controls are in one module, but all the sensors report to a different module. So in other words, the scan tool with the bidirectional, the module with the bidirectional control doesn't show you the PIDs for the parts that are measuring the movement of the bidirectional controls.
Oh, that's strange.
That's messed up.
But yet they're moving.
Yeah, so how do you know if it's moving? So I can turn it on, but I can't see the PIDs. If I see the PIDs, I can't turn it on
Right.
because it's two different modules.
Yeah. I ran into that in the Apollo.
Yeah. So, I mean, and it's not the Apollo's fault. It's how they're building the stupid cars.
Right. I thought it was Apollo's fault. I mean, this thing's a piece of shit.
I know you did.
Why did I pay all this money for this thing? I can't. Yeah.
Right. So here's an example, source and destination. It's confusing because not all sensor PIDs are sensors. Here's some example. All of the bust values are bust outputs. So here we have a bunch of PIDs. This is a factory scan tool, and Chrysler is at least nice enough to tell us, hey, some of these are factory and some of these aren't. And shoot, it is break time. So let's take 10.
Yep.
I'm going to take a call.
All right, bud. Where's that that piece of paper that give the official documents that I'm on the board, the mechanics union board?
It's over here somewhere. Where it said it was sent by certified mail.
Yeah. Remember the address was incorrect and I gotta get it. Did you send a picture of that to Kevin?
No, but I will. It's right here. I think it's on the table.
We're gonna do spring cleaning around here one of these. Where everything gets shoved into the hallway. Remember?
I think it's over here somewhere. Do you know?
You doing your meeting?
Thinking about it.
I'm gonna be here for another 9 hours.
No, go do. You want anything while I'm out?
Can you go by Costco? I think I have some. We need to get some it's in a pink bottle, shampoo.
This thing working? Okay. Make the-
Ryan, you turn on the mute.
Sorry about
There
that.
you go. There you go.
Hey, thank you. You think my screen would have been yelling at me? Usually it yells at me if I talk with the mute on.
I cannot yell. I have to do the signal.
Yeah, usually it yells at me on the screen, says I'm muted. I don't know why I didn't do it this time. Okay, so the key point on what we were talking about before our break is that without the scan tool PID source detail, like we saw on the last slide that Chrysler gives us, the best way to identify the source is with a wiring diagram of the system, not the network. If the system diagram includes more than one module without a clear connection besides the network, then the information is network traffic. So if I have a PID that is not in the desired range, before I start diagnosing the sensor or run right out to the sensor, I need to step back a minute and make sure that that sensor is actually connected to that module and that it's not bust information. Because many times, if a module might not convey information, so it could be a sensor problem. Hey, I can't trust the sensor, so I can't share it. Or it could be something going on or a missing module. Therefore, the module that is supposed to be giving me that information isn't sending it. Therefore, for that PID, I'm going to give you a default value. So here we have AC clutch control. Another great we use information combination with the scan to output controls is the air conditioning PID examples from the previous slide. The AC clutch is a bust output, so you can't control the clutch using the actuator's bidirectional control in the HVAC module. Instead, the wiring diagram was used to prove it was in the TIPM module, which is our gateway module. So then I had to go to the TIPM module, and that's where the AC control is. So imagine you're diagnosing an HVAC system. The compressor doesn't come on, and you'd like to know, hey, can the computer even turn the compressor on? Because that'd be a lot quicker than trying to get access and test stuff. And then you hook up your scan tool to the HVAC, and there's no bidirectional control to turn the AC compressor on. But wait, where's the AC compressor connected to? Oh, it's connected to the gateway module, the TIPM. Oh, let me go look in the TIPM. Oh, look, bidirectional controls in the TIPM, or functional tests, as we call it now. I can turn the AC compressor on from here. Right, and I've seen that. You're muted, Daniel.
I was in a Duramax diesel, and I think the glow plug controls were in the transmission module.
Yeah, could have been.
It was something crazy like that, and I was looking and looking, like, what the hell? I know it has this, you know.
Yeah, we see a lot of the after treatment controls on the Power Stroke or on the glow plug module because it provides power for the heaters for a lot of the stuff. So, I mean, you see different stuff. So the controls, if you don't find the controls in the module you're working on, don't assume that your scan tool is a piece of junk. Or
that's what I did.
You know, step back a minute and go, wait a minute, where is this hardwired to? In the case of Nissan, there's a lot of stuff that the bidirectional controls are in the intelligent power distribution module. So,
Right.
you know, right? So I'm trying to control HVAC. I can't control it from the HVAC. I got to go to the intelligent power distribution module. Now I can turn the compressor on. You know, so because that's where it's wired to.
So before you go in, you cannot find it. So you have to go look on a wiring diagram, see where where the network going to the module.
Exactly. And we're really not wasting any time because if we find out that it's wired to the module that won't give us control, then we know maybe our scan tool is a piece of junk or the manufacturer never gave it to us. And same with sensors. But if I'm going to diagnose a sensor with an incorrect value, I'm going to pull the wiring schematic up anyway. So we're not wasting any time. We're just getting good information instead of just jumping underneath the hood and start tearing at a sensor.
Wow,
So-
that's good to know. I didn't know that. Wow, that's pretty
So
good information though.
good. I'm glad. There's also what we have called the scorched earth approach. When a module or system isn't communicating or isn't operating properly and there's no clear diagnostic path, the best first step may be a reset. We see this simple step fixing more faults every year. So it's becoming a huge risk to start diagnosis without first starting some forced amnesia. In other words, and I've done this with quite a few cars where I couldn't talk to anybody on a scan tool. I've got a network that's got shorted to voltage on it or shorted to ground. And it's like, before I go any further, I'm going to disconnect the battery. What do you do if your phone stops working and doesn't work?
Restart.
Turn the power off, pull the battery out, whatever. What do you do on your desktop or laptop if it freezes up and doesn't work? Disconnect the battery. Well, what do we have on cars? Computers. What's in cell phones? Computers, right? So why wouldn't we do that? If I do a power disconnect and I get back to the same place, now I know it's going to be a long day. On the other hand, I do a power disconnect and everything works. I'm a genius. Thank you. Perform factory power disconnect procedure. Reinitialize network 1 hour. Right? So here's the Ford IDS, which is Ford's factory scan tool. This example is from a 2015 Explorer. Or battery replacement. And the battery replacement specifically says to perform the BMS reset, but not in which menu to find. So does this mean you need to read instructions when replacing a battery? Yes. So, and I've had a couple people in this class that work at Ford dealerships. They have cars in every day with problems. That the problem is someone put a battery in and didn't perform a battery reset. To put an example, a lot of cars today have start-stop technology. The start-stop will stop functioning on a Ford if you don't do the battery reset after replacing a battery. Did I mention there's no codes? So also, I got to do it, and I've done this on BMWs or other cars. It's like, which module do you find the stupid procedure in? It make way too much sense just to have a battery module and we can do it there. Oh, no. In this case, it's in the body module. Why is the battery in the body module? Well, because that's where they put it.
So there's no rhyme or reason of what's okay.
None. That's what makes it challenging and frustrating at the same time, because, and that's why I think a lot of technicians just give up too early.
It's like an Easter egg hunt.
It is. And that comes back to what I originally said about scanning all modules. How do I know which modules to check for something until I know everybody who's on the playing field? And then it's kind of, well, let me go to the biggest odds one first. You know, did they put it in the PCM? Did they put it in body? Did they put it in, you know, is there a battery module? You really don't know till you do a full scan and see who's in the network.